Hey guys, today we will be discussing on LIS, which is the Land Information System for Survey and Mapping. Land Information System is a geographic information system for cadastral and land use mapping which is typically used by local governments. Why do we need Land Information System? It is firstly to provide land parcel information, which is the basic unit of access and control of land to make land use decision. Second, to provide the reliable information necessary for many public programs such as land planning, infrastructure development and maintenance. Thirdly, to provide a base for land markets, development and other economic activities. The last but not the least, to help in updating maps. So under geographic information systems, we have two information systems which are land information system and socioeconomic information system. Land information system can be divided into three systems which are parcel-based information system, network facility information system, resources or environmental information system. So what is the concept of LIS? Parcel-based LIS are based on land parcels where land parcels are considered as the key feature. A typical LIS uses cadastre as a primary document. The multi-purpose LIS concept consists of geodetic control and a base map that allows spatial registrations of various data layers, each representing a data type or theme.
Next, instrument, hardware and software. The example instruments used are theodolite and total station. Most instruments screw onto a tripod when in use. Theodolite is an instrument for the measurement of angle. It uses two separate circle protector or LEDs to measure angle in the horizontal and the vertical plane. A telescope mount on trunnion is aligned vertically with the target object. Total station is development of the theodolite with an electronic distance measurement device, EDM. A total station can be used for leveling when set to the horizontal plane. Since their introduction, total stations have shifted from optical mechanical to fully electronic device. For hardware is computer on which GIS or LIS software run. Nowadays, there are a different range of computer. It might be desktop or server-based. In order for the computer to perform well, all hardware components must have a high capacity. Examples of hardware components are motherboard, hard driver, CPU, graphic card, printer, and so on. All of these components work together to run GIS software smoothly. Next, software. Software provides tools to run and edit spatial information. It helps to query, edit, run, and display GIS data. There are several software that can be used in LIS, such as LDAS. LDAS are instances of the Land Information System, LIS, Land Surface Modeling software that have been configured for specific domain and purpose. Land Data and Simulation System use sophisticated numerical model of physical process to integrate data from multiple ground and space-based observing systems in order to produce field of water, energy state, and flux that are physically consistent and spatially continuous. Type of data. Type of data that has been used is spatial data and non-spatial data. Spatial data is data or information that identifies the geographic location of features and boundaries of Earth, such as natural or constructed features, ocean, and more. Spatial data is usually stored as coordinate and topology and also is data that can be mapped. Non-spatial data, also called attribute data, is data that are related to a specific, precisely defined location. Non-spatial data are mostly the attributes associated with spatial information layers. The example of non-spatial data is attitude, opinion, gender, environmental parameter, soil parameter, groundwater detail, and mining parameter. Methodology of work. First step is pilot study to identify project component on a smaller scale. A pilot study would be required to define the technological requirement, cost implication, data requirement, user needs, and training requirement for personnel involved in the implementation of LIS. An area is selected and the data model developed and tested on a real-life situation to ensure the suitability of implementing LIS. Next, spatial and non-spatial data automation. The production of both spatial and non-spatial geographic data is very crucial for the success of any LIS implementation cycle. It is estimated that spatial data capture and updating techniques used to make data digitally available constitute about 80% of total resource required for LIS implementation. Digitalization and preparation of data require high initial investment in money and time. Normally, there is a considerable time lag before the actual benefit begins to reach the user. Implementation of the LIS require department and staff to switch from traditional land information management system and adapt the new tools and methodology. Step 2. User needs study and data dictionary. Once the pilot study for the project has been carried out and the results are considered feasible, the user needs are studied and the data dictionary defined. The data dictionary is prepared by user to clearly define the type of data that should be included in the database, what each data item is called, how the data is assembled and structured, how accurate it is, and so on. In order to build a comprehensive database and that meets all user requirements, all potential users of LIS must be involved at this stage. The last step is implementation of LIS. Automation of record is the most important phase prior to LIS implementation. There are certain issues that must be taken into account by the authorities when enforcing LIS. This should include availing of the right information at the right time to make decisions for efficient planning and management, and achieve consistency in the uniformity in policies, standards, and regulation for the whole country.
So, for the field phase, which means data collection, after decide on a company that will do the works on new cadastral survey, worker and investor endorse a contract for the period of 24 months in which service provider agrees to finish off all work. In the planning phase of fieldworks, all the existing originals such as digitized cadastral map, inventory list, topographic maps were utilized. With using autocopter, we made digital orthophoto or DOF and digital terrain model, which means DTM, totally for the objective of planning fieldworks. DTM and DOF are giving intuition into the structure of the terrain, building densities which surface or nurture and which are below forest. Then classification of cadastral parcels was done corresponding to a predefined proposal in mean that the section of the project is split up in the grouping. The range of groups varied on the intensity of cadastral parcel composition of the land and whether it is occupied or not occupied part of the development area. So the next step, which means is office phase, processing of collected data. The computer hardware utilizes a computer system, Colida Total Station and a scanner, whilst the software used in the situation are AutoCAD 2009 and ArcGIS 10.1. The data for the outside survey of the property was taken out using Colida Total Station, and the parcel spatial record was produced all through computerized system from the scan layout that was registered in ArcGIS. The obtained information of the parameter have been plotted in AutoCAD and the plan layout examined and transferred to ArcGIS, georeferenced and digitized to make data for the parcel. At this phase of the working, data gathered in the field is managed and are planning for the procedure of public review. Elements that characterize them are included to each gathered field data. Thus, for instance, each calculate point is exclusively labeled by its number, type, structure of origin and along with the way of maintenance. The obtained data was manipulated to produce full information or data for the property. A database was established for the estate employing the spatial data and non-spatial data of each parcel. So this is the vector data model, entity relation, and the area entity, which means parcel and its element. So after that, we will be analyze survey. After a worker complete all the proceeding in the assigned period of 24 months, this the figure will illustrating the sequential structure of everything movement on the cadastral or the land information survey that have been made on. Amount within highlight cells is associated with number of genetic authorities who take part in that part of the task. The structure indicates that the field phase of the work out carried part in half of the assigned period, and the additional half remain office phase. We need analyze the data and control data. Terrestrial and satellite measurement technique have been applied for 40% of the area, while photogrammetric and more technique of survey have been utilized for 60% of the area. The last thing is public review. After the worker has gathered and managed all the required data for cadastral public credential, in the process of public review, this information turned out to be official. In the process, cadastral and land register committee cooperatively conduct a public review process by welcoming people who are documented in the eventually list as owner. Throughout the survey, the property records of clerks create new land registering document, including the data on cadastral parcel and title holder, and indicating the authentic situation.
The image displayed shows the example of digitization result. The output were created from the ArcMap software. This shows some of the example of land information system that frequently being used to get the result needed. In ArcMap, the digitization process is applied as it refers to the process of converting features on a paper map into digital format. The scanned map was digitized using the latest ArcMap software. The example displayed shows the result of the process of digitization of the RIM after it has been georeferenced with coordinates in UTM ArcDatum and transformed to coordinates in UTM WGS 84. It was done so that integration with data such as Google Earth Maps, which are in UTM WGS 84, is possible.